So yesterday we started out with 9.1, dealing with the properties of square roots. I asked you to complete on page 279 of your student journal number 2, number 6, and number 8. So, on number 2, go ahead and tell your neighbor what you got. Student journal. Okay, let's check it out. So, perfect square that goes into 48 is 16. 16 times 3. And this negative 1's hanging out there. Remember, if the negative's on the outside, we just circle it and move it down. Square root of 16 is 4. We're now done with that. And this is root 3. We can't simplify. So negative 1 times 4 is negative 4 times root 3. Now, if you put negative 2 root 3, you made a common mistake. You took the square root of 4 after you took the square root of 16. So once you actually take the square root, the root symbol disappears. You don't just keep breaking it down. Okay? Anyone do that? Okay, all right. All right. Numbers, any questions on 2? Number 6. Okay, negatives on the outside. So keep that negative 1. And then we have root 6 on the top and root 49 on the bottom. Square root of 49 is 7. So keep that and root 6. So we get negative 1, root 6, all over 7. Can't simplify the root 6. So negative root 6 all over 7. Questions there? Really, with fractions, what you're trying to do is you're trying to break it apart first. So on number 8, we'd break apart the 49 and the x cubed on top, and we put it under its own radical. And then on the bottom, we would have a 64 and a y squared. You're not allowed to have square roots in the bottom of a fraction. Okay? If you do, you have to do what's called rationalizing it, meaning getting the radical out of the denominator, out of the bottom of the fraction. So in this problem right here, this 64 actually simplifies to 8. So now that part of the root's gone. And y squared actually simplifies to y. So that part is gone. So now we don't have to worry about having a radical down there. It's okay. On the top, it's okay to have radicals. However, 49 simplifies to 7. And then x cubed, remember if it's an x cubed or if it's an odd power, you're going to make it an even and one more, right? And so the square root of x squared is x and root x. All right. Questions? Okay. Tell your neighbor how you did on that page. Do that. What a mean head. All right. Any questions on those 3? Next page. We'll come back to the bottom of those, 9 through 12, a little later. But I asked you to do number 14 and number 15. So we'll break these apart. We get root 8 and root 100. Remember, you're not allowed to have a fraction in the denominator. You can't have a fraction in a radical either. These are all things that we're not supposed to have there. So this root 100 breaks down to 10, so we're good there. Root 8 over 10. Is that good? Can root 8 break down? Perfect square that goes into it? Yeah, 4 and 2. Root 4 by root 2. What's root 4? 2. So we now have 2, root 2 on top, all over 10. We good there? Yeah, you can reduce. Reduce what? 2 over 10. It becomes 1 over 5. So everyone write down on your paper how you'd write that as an answer. Hey, go ahead and show your neighbor what you put there. How many put root 2 over 5? Good. Don't need the 1, right? It's implied. All right. Number 14. Or, excuse me, number 15. So this one here we're going to break apart to its individual pieces. So root 3, root x squared, root y cubed, root 80, root x, root y cubed. All right, tell your neighbor which of those 6 parts is perfect. All right, which one's perfect square? X squared, yeah, x squared is x. Done with that part. Can you reduce? Nothing else is perfect, so look to reduce. Does 3 go into 80? No. Nothing else goes into 3 other than 1, so we can't reduce that. X and root x, can we cancel those? No, one's inside, one's outside. They can't play with each other there. It's like you're like grounded in the house and your friends are outside. Sorry, man. Okay? I know, so you have to text them. Okay? Y cubed and y cubed. They're both inside. Can you cancel them? Yes, you can. They're the same. So they're gone. So to clean it up a bit, right now we have x times root 3 on top. And on bottom we have root 80 and root x. Now, we cannot leave it like that. Okay, now you could write that as root 80x, or you can write it as root 80 and root x. It's up to you. Okay, but the problem is right now, you are not allowed to have a radical in the denominator. Okay, so we need to get the radical out of the denominator. All right, so you could do it in 1 step or you could do it in 2 steps. I'm going to show you how to go about this, doing it in 2 steps. First thing is I'm going to get this root x out. Okay? So to get rid of that root x, I have to multiply it by a special number 1. Okay? The only thing you can multiply by and not change the value is the number 1. Like if I multiply 7 by 1, I get 1. If I multiply this thing by 1, I get 1. It's just the special number 1 because the number 1 I am going to use is root x over root x. Now tell your neighbor why I chose root x. Why didn't I choose like root y? Yeah. Yeah, when I chose root x because it's right here. If this was root y, I'd make it root y. This isn't going to affect the 80 at all. But when I go root x times root x, what's root x times root x? It's root x squared. What's the root of x squared? X. So when you multiply a root by itself, you get the thing that's inside that root. So this times this becomes that. Bless you. And then up on top, I have x, root 3, root x. Okay? Now, I don't just have x on bottom. What else is still down there? Yeah, the root 80. It's still a problem we have to deal with. Quinn?
What about the root x on top? You multiply it on the bottom, the root x on top of the one you multiply.
Yep. So you did it right here. So it just got attached to this. It became part of this train. Yep. Okay, root 80. Tell your neighbor how you can get rid of root 80.
Could you multiply it by root 80?
No. Oh, you mean could you have?
Yeah.
Yeah, you could have done it in 1 step. Okay, multiply by root 80 over root 80, which gives you Root 80 squared, which is 80. So on the bottom now, you have 80 and x. On the top, you have x, and you have root 3, and you have root x, and you have root 80. It's like you just keep adding little pieces to it, man. That's ridiculous. Okay, before I mess with the top, Kai said, hey, could we just multiply by 80x? You could have. That would have been the one step. So rather than just breaking these apart, you could have multiplied by root 80x, which would have moved everything up at once. It's faster. That's probably the way I would do it if I wasn't teaching it right now. Okay? But from this, I can put 3 and 80 together. Okay? However, 3, nothing goes into. That's perfect. Does anything go into 80 that's perfect? 10's not perfect. Four? Anything else? No? 10's not perfect. Yeah? 5's not perfect. Got to test perfect numbers. What are our perfects? 1, 4. What's the next one? 9. 16. Testing all the perfect squares. 16, 25, 36, so on. 16 goes into it. How many 16s? 16, yep, 5. What's the square root of 16? 4. 4 root 5. So we're done with that now. We're done with that. We're done with that. We're done with that. We have everything done there. On top, everything's done on the bottom. Put the whole top together. What do we have on top? And then what do we have on bottom? Write your answer out there. All right, very good. Volunteer, what's on top? Tara? 4x and square root 15x. Yep. Good. Good job. 4x, root 3 and root 5 is root 15 and root x. What do we have on bottom? 80x. Are we done with that problem? No. Tell your neighbor what you can do to that problem. All right, volunteer, what can we do to that problem? Jilly? Simplify it. What cancel? Good. 4x and the 80x. So the x's cancel. How about the 4/80ths? What's that become? 1 and 20. So the actual answer is root 15x over 20. Can we cancel the 15 and the 20? Take a 5 out. No. One's inside, one's outside. They can't play together. Okay. Sad. All right. Hey, that's a lot of stuff. Yeah. Yep. You guys, you have to simplify all the way. It's a key piece. That's why we actually are going to spend a third day on this. We're going to spend tomorrow on this as well. This is an important concept that's going to carry throughout Algebra 2 and Math Analysis, Pre-Calculus, Calculus, all those courses. You have to know how to simplify, and it has to be just like simplifying a fraction. You have to be very efficient at it. Okay? I know it's not the most exciting stuff, but it's a lot of math that you have to learn right now. All right. Any other questions on that? Okay, once again, we are skipping this part down here for a minute. And we're going down to numbers 22 through 27. Tell your neighbor what you got for number 22. Oh, this is where you got? Yeah. All right. How many of you got stuck on these? They're different than what we looked at. Yep. What are you doing, man? Huh? Oh, there you go. All right. So 3 root 8s and 3 root 2s. You're adding 3 root 8s and 3 root 2s. Are you adding the same thing together? Now, like if I gave you 3 pennies and 3 quarters, are you adding the same thing together? No. You are not. You have 3 of these, and you have 3 of these. You cannot combine those because they are different things. Okay? It's like me counting boys and girls in this class, or counting up the boys in here and then including the girls in my count. They're not the same. Counting people with green hair and people with blue hair and people with red hair and people with black hair and people with brown hair, counting them all up, they have different color of hair. Okay, we are we are classifying them as things. This is a root 8. This is a root 2. So we can't add them up. If you want to add them, they would either both have to be root 8s or they both have to be root 2s. They're unlike terms. The other way to think about it, think back to this. If I said you had 4x and 3x, how many x's is that? You have 7 x's. Okay? Now how many x's do you have? You have 4. You can't put them together because you're counting up different things. Okay? So, with this, can I simplify root 2? Can I simplify root 8? Is there a perfect number that goes into 8? 4. Okay, I want everyone to simplify root 8 on your paper. What's it become? Okay, tell your neighbor what you got. Three root 4 times root 2 plus 3 root 2. This part's still the same. What's 3 and root 4 make? What is 4? Root 4? 2. So what does it make? It makes 6. 3 times 2 is 6. Root 2 plus 3 root 2. Tell your neighbor what you can do now. Okay, what do we end up with? How many root 2s? You have 9 root 2s. You have 6 here and 3 here. You have the same thing. Now you can put them together. 9 root 2s. All right, number 23. Go ahead and tell your neighbor what to do there. How to start it out. Same roots. Try to get the same roots. Simplify those radicals that you currently have. All right. Root 18, what's it break down to? Root 9 and root 2. Good. Okay, so root 9 is 3, so that's 2 times 3, root 2, or 6 root 2. Minus, what's root 20 break down to? Root 4 root 5, so we get minus 2 root, this becomes 2, and this is root 5 still. So we get 4 root 5. Okay, so if you think of them as separate parts, these are kind of all separate problems. At the end, we're going to put it back together. Okay, and 2 root 5. Can we simplify that? No, so we bring it down, 2 root 5. So what 2 pieces can we put together here? The root 5s. So I have negative 4 root 5s and negative 2 root 5s. How many root 5s? Negative 6 root 5s. And then our 6 root 2 that we put on the front. Okay? The 6's are the same, but the roots aren't. So you're counting different things. Therefore, you cannot put those together, even though the 6's are the same. All right, questions? Okay, we're going to skip 24 for a minute. I want you to take a look at 25. Tell your neighbor what you should do there. What do you think you should do? Good. Always look to combine what's in here first, but then you can't put root 6 and 2 together. I heard the word distribute. Yeah, distribute it. Multiply them up. Can we multiply roots that are different? Yeah. So you have 2 root 30 plus 2 times 2 is 4 root. Just put the root on the end. 2 root 30 plus 4 root 5. Since we can't simplify root 5 or root 30, there's not a perfect square that go into them and they're not the same, you're done. All right. You got it? Okay, this next problem is called a conjugate. These are conjugates of each other. Conjugates. Okay? Why are they conjugates? Like, I know, you don't know what it is, but, like, why are they conjugates? What? Yeah, the same numbers, just a different sign. One's adding, one's subtracting. Okay? If we're multiplying these two conjugates together, please note what happens when you do that. What's root 7 times root 7? Root 7 squared, or? Yeah, root 7 squared, I'll write it out. Root 7 squared is, these cancel, I get 7, or the root of 49, right? What's root 7 times root 3? That's root 21. Okay? What's root 3 times root 7? That is root 21. That's negative root 21. What's going to happen right here? They're going to equal 0. You're going to add root 21, subtract root 21. They're going to cancel out. What's root 3 times root 3? That's root 9. That's negative root 3, right? So root 3 times root 3, that's negative root 9, which is negative 3. Right? So you get negative root 9. Or if you want to think of it like we did with the 7, it's negative root 3 squared, which is 3. So what's my answer in all that junk? It's 7 minus 3, which is 4. So all that mess became 4. Now the quick way to do that, that's the difference of two perfect squares. How many remember that pattern earlier in the year? When you had this, a plus b times a minus b. You just squared this and squared that, and you put a subtraction in between. Anyone remember doing that? We did factoring. Yeah, that's fine. You can still use this method, but remember, all you're doing is squaring that and squaring that and then putting a subtraction in between. Now, why is that important to me? Because these problems up here that look fairly difficult, number 17, tell your neighbor what's wrong with this. Why is it not simplified right now? Okay, volunteer, why is it not simplified right now? Quinn? It's okay to have the negatives on the bottom, but it's not okay to have that root right there. Now, Earlier today we said, hey, you just multiply by the root over the root. But that's when you don't have things being added and subtracted to it. This whole thing you can think of as a parenthesis set. If I want to get rid of that root, I multiply this whole thing by its conjugate. Okay? So I'm going to take the 5 over negative 3 minus 3 root 3. And I am going to multiply by 1, again, just like we did earlier. But that 1 is going to be in the form of its conjugate. Tell your neighbor what the conjugate of this is. The 5 will have nothing to do with the conjugate. Just the parentheses. Anyone want to take a shot at it? Negative 3 plus 3 root 3. Negative 3 plus 3 root 3. So you got, when I'm looking at this, what I see is I see two different terms. I see this term, and I see this term. Take your earbud out. Okay, look at me. Next time we do that, you go outside and do it. Or say, excuse me, keep the earbud out. And if you're going to be in my class, get your workout and start working. Otherwise, you're wasting my time. You're wasting yours as well. Hey, recognize those two different terms. Right? So there's the terms. The only thing that you're changing is you're making it a plus sign in there. All right, I want you to multiply this by that. Now, just like we did down here. Multiply these two things together on the bottom. I will concede that this is tougher stuff. I've never taught conjugates to an algebra class before. Okay? These are Common Core standards, so the things you're going to have to learn and be able to do on your exam your junior year. When I ask you guys to do this, though, I don't expect you to be able to do it really well, but I do expect, when I say multiply that out, I do expect everyone to try. Okay? So there's the quick way, which is recognizing the pattern we talked about a minute ago with the a squared plus b squared or a plus b, a minus b. That's what you have here. If this is a, and this is b, and that's a, and that's b, really all I'm doing is taking this and squaring it. What's negative 3 squared? It's 9. And then I'm taking this and squaring it. What's 3 squared? 9. What's root 3 squared? I've heard 3 people say it right. What is root 3 squared? Root 3 times root 3 is? Root 9. What is root 9? 3. Anytime you square a root, what will you get? The thing inside it. So root 3 squared is 3. And then a plus b times a minus b is a squared minus b squared. A squared, b squared. What does this equal? 9 minus 27. What is that? Negative 18. So my denominator has now become negative 18 up here. Okay. So for those of you that think I just did some crazy black magic or something, you're like, I don't know, that doesn't mean anything to me. I don't get what he did. Then multiply it out. But it takes your math, right? You got to go negative 3 times negative 3, which is 9. And then negative 3 times 3, which is negative 9, and then root 3. And then negative 3 root 3 times negative 3 is positive 9 root 3. The reason that happens is because that part becomes 0. Then negative 3 times that is negative 9 times root 3 squared, which we know as 3. So this is 9 minus 9 times 3, which is 27. That's how we get that 18. You can do that. It's quicker if you know the pattern. It's called the difference of two squares. That pattern will never go. You will use that all throughout high school. How do I know? I made it through high school. And I teach it now. Okay? That's how I know. So, you will use it. What's the top going to be? Tell your neighbor how you multiply this by that.
You distribute.
Okay, you do distribute it. Go ahead and do it. Distribute it. It's just that times that. Negative 15. And that times that. Plus 15 root. Oops. 15 root. No, not 15. You can multiply the number inside or outside with the number outside. Outside can only play with outside. So it's 15 root 3. So my answer is negative 15 plus 15 root 3 all over negative 18. Holy moly. Yes. Can we put these two together is what you're asking? You cannot put these together. It's a good question because they're multiplying right there. So you got to follow the order of operations. You have to multiply those two things first. There's one other thing you can do to this, though. Does anyone know what it is? You can simplify it. What goes into 18, 15, and 15? It has to go into all three terms. 3. So this would become negative. Negative 6. This becomes negative 5. And this becomes 5. No, the root 3 is attached to the 15. So when you do something to that 15, you're doing it to the root 3 at the same time. That is your answer. Okay. Once again, I don't think this is easy. I think it's tough, but that's why yesterday I introduced simplifying radicals. And today introduced this. And tomorrow we'll introduce the cubes. Okay, the cubed roots. Because I want you guys to be successful at it. If I did it all in one day, and introduced it all in one day and gave you one day to practice, you would be struggling. Okay? Yep, tomorrow it'll be cubed. So tomorrow we're going to go through, if you take a look at that previous page, those ones I had you skip, tomorrow we're going to do all the cubed root stuff. Oh, sure. Just do it today. All right? Any questions right now? Okay. Before we wrap this up, actually, while I'm handing out your assignment for today, I want you to take number 18, 3 over. Actually, you know what? There's too many 4s in number 18. Let's get one without other things in it. Let's go with number 19. Take number 19 and simplify it. As far as you can. Get as far as you can on it. All right. What's my first step? Yeah, multiply by the conjugate. What's conjugate? Good. Well done. So when we multiply this bottom by that bottom, we end up with root 2 times root 2 is root 4, which is? It's just 2. Okay? And this times that, what do we get? Negative 25. Roots root 3 and root 3. Come on, root 3 times root 3 is root 9, which is 3. What's 2 minus 25 root 3? Or 25 times 3?
75.
Negative 73. So our denominator becomes negative 73. Okay? Remember, the pattern, when you're multiplying here, you're squaring that, and subtracting the square of that. That's it. So you multiply root 2 by root 2, and negative root 5 root 3 by positive 5 root 3. You get our negative 73. Then we multiply the tops. 4 times root 2, and 20 root 3. Okay, how many got it? Good job. How many of you got most of it? A chunk of it. Good. All right, there it is. Questions on it? Hey, you guys, on our assignment it says simplify a lot. How do you know what things tells you what tells you it's simplified? No, I mean it says to simplify, but how do you know if something is not simplified? Okay, so first thing, you can't have a number in the radical that a perfect square goes into. Okay? You cannot have a fraction in the radical. And you cannot have a radical in the denominator. Okay? If you're like, well, my answer doesn't have any of these problems, then it's simplified. Otherwise, it's not simplified when you're dealing with radicals.